Okay, welcome once again to our online tutorial. Today we're going to be discussing a very fantastic topic that is relevant in every aspect of mathematics, be it intermediate, elementary, or advanced mathematics. You need to know this concept and then these symbols for you to understand mathematics properly. Now, what the topic we're going to be discussing today is called the number system, right? It is the number system, the number system. Now, what is number system and then how important is this in mathematics? Now, clearly, what you see, number system are just a set of numbers, how they are arranged and how important are they for understanding general concept of mathematics. Now, the first number system is the natural number. Now, this is how it is represented. This is the natural number. Now, the natural number are the set of counting numbers, the numbers that you already know, right? So 1, 2, 3, now up to infinity. These are set of natural number, and it is indicated by, you can see the symbol n for that, right? So when you see this symbol n, is set of natural numbers. Now, if you include 0 to this set, you will get the set of whole numbers. Now, whole numbers, they are the set of natural numbers, now with 0 included, right? You get the difference? When 0 is included, it is now the set of whole numbers. Then subsequently, we can go straight to the next set. If you know, this set is called the set of integers. Now, this is integers. Integers. Now, what are integers? Integers, they are this set of numbers, but when you have both negative numbers, so I can have from negative infinity up to, let's say, you have -3, right? -2, -1, 0, 1, 2, 3, so on and so forth. Now, what's the difference? With negative integers, you can be able to solve mathematical equation of the form x plus 1 is equal to 0. So here, if I take 1 to the other side, I get x is equal to -1. You can't do that in the set of numbers or in the set of whole numbers, right? But you can get that particular equation solved using the set of integers. Now, subsequently, we'll move to the set of rational numbers. You see, rational numbers. Rational numbers. What are rational numbers? Now, any number you can represent as a ratio of integers. So it is a ratio of integers. So the numbers can be negative or positive. P upon Q, right? Now, this particular number is defined such that both this P and this Q, they belong, this is element of the set of integers, right? Provided that Q over here is not equal to 0. You can't have 0 in the denominator. If you see any number represented like this, for example, 1 over 2 or -1 over 7, you can see clearly that this is an integer, this is an integer, and they are represented in this form. So you can say that kind of number is a what? Is a rational number represented at this form. Now, we also have a set of irrational number. Irrational. This is irrational numbers. So these numbers, they are also in the form P upon Q, right? But their decimals are not terminating. The decimals don't terminate. they don't terminate. They do not terminate, right? Terminate, good. And they are not repeating, and not repeated. Like, for example, you have like 1/2 is the same thing as 0.5. Now, this number is rational. You see the decimal terminate is rational. Rational. This is part of these rational numbers, right? But decimals like 0.1423, 127, and keep on going, then it is irrational, right? It does not terminate and it is not repeating, because a number that is like 0.121212, you can say it's rational because it's repeating, but it is irrational when it does not terminate and does not repeat. Then you say that number is irrational. For example, square root of 2 is an irrational number. In the next video, I'm going to be proving why we say this number is irrational. Then we have two sets of numbers to go. We have the real numbers. So the real numbers, you can have any number at all. Any number at all is part of real number, so long as it's on the real plane. So the real number can be any number at all. Both irrational numbers are part of real numbers. The rational numbers are real numbers. All set of integers are in the real plane. Then whole numbers are also in the real plane. Then the natural numbers. So every number you have, like you can have pi is the real number. The rational number -1 is also real. 0, 1, 2, any number at all. 2.737 continuously, they are all real numbers, right? All real numbers. Negative, positive numbers are real numbers. Then we have, lastly, we have the complex number. Complex number. Complex number, they help us solve equation of the form x squared plus 1 is equal to 0. If you decide to solve this algebraic way, you have x squared is equal to -1. Then you end up taking the square root of -1 to be able to get the value of x. So any number you see of this form, you can only get this solution in the complex line. And the complex number look like x plus iy, where this is the real part of the complex number, then this part is called the imaginary part. Good. So stay with me. In the next video, I'm going to be doing a lot of example and a lot of problems we're going to be solving using this particular set of number. So I will see you in the next video. Stay tuned. Please like and share if you have anything new. If you have gotten any value from this particular video, you can subscribe, like, and share. You'll be seeing more of this in the subsequent example and as you go far in mathematics education. Thank you and see you in the next video.